why is a to the x equal to e to the ln a times x? And why is this fact important? Let's recall that e to the x and ln x are inverse functions. What does that mean? Well, when we compose them, we should get x. In other words, if we take e to the ln x, it should be equal to ln e of x, which is equal to x. When you compose two inverse functions together, you get x. Simply put, a is equal to e to the ln a. Therefore, a to the x, if we want to emphasize the fact that it's a exposed to x, we put a between brackets. And we know that a is e to the ln a. So it's e to the ln a to the x. Now, you may say, why taking a term, an expression that is so simple and make it so complicated? You see, when you're calculating the derivative, a to the x, like 2 to the x or 3 to the x, is very difficult to differentiate. However, if you write it in the form e to the ln a x, therefore you will be able to take the derivative as the derivative of a composite function. Now, we all know that the derivative of e to the x is e to the x, right? The only difference between the two is that the one that we have here is a composite function. It's e to the u. We also remember that ln a is a constant. So our u is going to be ln ax, and u prime will be just ln a. E to the ln x, that's what the derivative is equal to, times ln a. Remember, e to the u prime is equal to e to the u times u prime, composite function. E to the ln a x is equal to ax. Therefore, we're gonna have ax times ln a. Now, in most books, ln a will be written first, so we see that the derivative of a to the x is equal to ln a between parentheses times ax, and this is known as a formula.